Hello everyone, welcome back to the series Reading Laravel Source Code. And in the last episode, we stopped here in the application, the handle request method. So we saw how the kernel was created, and this was through the application container, right? And now that we have the kernel, one thing that I noticed reading the rest of this method was that the kernel here, if we do a dump and just, you can see that it has all the middleware variables initialized, right? But that's not so clear where that happens, because if we go to the kernel and eliminate HTTP kernel, and construct, you can see that it's not doing anything related to, well, it's syncing the middleware to the router, and we will take a look at that, but it's not initializing those variables. So it's receiving from somewhere, some other code, it's doing that. And I wanted to check, of course, where was that part of the code, because if you do a dd here, we'll see that once it's finished the constructor method, you can see that the middleware are not initialized. No value there. So you just fix this. So stop. Yeah. So where does the code lives, right? To do that. And one thing that we didn't look when we were reading the bootstrapping, if you go to the Bootstrap app, we read this with routing, right? We also saw that the application has a constructor method that calls all those register-based services, bindings, and it also has the configure, right? Which it's going to use the application builder to call with kernels, and here it's where the kernel, it's bound to the application with the singleton method. But we didn't open this with middleware, and I didn't, because I thought, okay, it's just an empty callback, it will do nothing, but it actually does. So this with middleware here, it's also in the application builder. And let me just open that for us here somewhere with middleware. Okay. So you can see here that it's accepting a callback, and the callback, it's just to really follow the application code to define more middlewares to be registered, right? This middleware class here, it's just a wrapper that helps adding and removing and ordering the middlewares. So it's just that. But if there's nothing here, the builder still do something. And the thing that it does is this: it register, and after resolving callback. And we saw that in the container, how the container has this container, and it's in the resolve, right? So we saw that it has this ability to execute callbacks, both when the resolving process started, so before resolving, and also after. So that's where the call to the callback, it's happening, the callback, it's happening. And here it's the callback, because the with middleware does just that. It register after resolving callback against the HTTP kernel class. So if we take a look after this happens, we do this app, you will see that we have after callbacks, we have one for the kernel, the console, and one for the HTTP kernel. I think there's more here as well, but we just didn't allow the code execution to reach there. But the kernel, it's the one, the HTTP, it's the one that we are looking for. And you can see that there's a closure for the inside the application builder class, etc., using the application builder, well, actually using the callback. But that's where. And the code here, it's really just checking, well, it's first creating the middleware helper, right? And I think this is just a default redirection. So redirect guests to in the logging route. It's just registering this. If you don't use the authorization, maybe this won't do anything because the root won't be there, right? But it's here. And then it's calling your callback, and the callback here inside a callback, it's just the thing you define in here with middleware. So if I just defined echo middleware application callback, I run this again, see it's calling here. And I removed the styles of the main page because it was getting harder to read those echoes that we do. So that's why it's looking bad, but for debugging it's better. So we will do that, and it calls our callback, our application callback, passing the middleware. So you have the opportunity to just register more middlewares in your application. That's how you do, right? Then it does the full middleware initialization, right? It just this page middleware here, I don't think it has anything by default, and I don't know exactly what it is. But the global middleware, the middleware groups, and the middleware alliances, they are all just the full Laravel middlewares, right? Information. So middleware, you have the full HTTP, trust proxies, handle what? Of course. Okay. This is, I don't know that. Just go there. We need middleware, no HTTP. There. Go. What is a course service? Take course service. Root. Oh, okay. Deprecated because all support Laravel versions now include the course middleware in the core. Right. Let me just fix this micro. Just getting lower and lower. So this package now cite that middleware, but still this was okay archived. Let's see, so it's part of the, I do vendor fruitcake HP course. It's still here. Yeah, that's exactly that. Course service provider. No, it's not exactly the same thing. Means Symfony HTTP Foundation. Okay, this seems to be the, yeah, the new one. library middleware enabling cross-origin resource sharing for your HTTP using application. Okay, let's not dive into this one for now. But that's that, and those two. So you have the other middlewares, and you have also the middleware groups, right? Web and API, and the aliases, because the middlewares can also work with aliases here. So all that, oh, and that priority also, it's important. So all of this information, it's initialized into the kernel from this callback here after resolving, and that happens because the kernel class needs to be resolved first before this can be called. I think because of also the dependencies that the kernel has, and this middleware, for example, does it use any dependency? So I think middleware, it's just inside the configuration as well, right? Configuration middleware, yeah. And no, there's no constructor. Does it use the app? That's silly. App. App. And or maybe like this. No, it doesn't. Yeah. So I think it's just really a repository or helper, not a repository, but it's a container. You can append, you can remove, you can replace, use. What is the difference between use and append? Define the global middleware for the application, and use, not append middleware to the application global middleware style. Append. Yeah, I don't know the difference here. But this is probably very well documented, because this thing, it's the thing you use when you want to register your middleware, right? So the basics middleware and registering. Responses, registry. You want to middleware to run during the request. You may append it to the global middleware stack in your applications. Right. And there any mention to the use. The middleware object provided with middleware closure is an instance configuration middleware, yeah, and is responsible for managing the middleware assigned to your application routes. The append method adds the middleware to the end of the list of the global middleware. If you would like to add a middleware to the beginning of the list, you should use prepend. Okay. Manually managing Laravel the full. If you would like to manage Laravel global middleware stack manually, you may provide Laravel's the full stack of global middleware to the use method. Then you may adjust the default middleware stack as necessary. So middleware use, and then you can change things here. So the use will erase, yeah, just pass whatever you passing here to the global, and the and prepend, they work with this. And what happens after you get global middleware? Values of a future array, and the middleware here might be the global. It's coming from the global. Right. So the array diff will exclude the ones that you have in the prepend and append that you passed already here. Then you will be able to find manually, as the documentation says here. If you'd like to manage Laravel global middleware stack manually, yeah, you may provide. Okay. All right. So that's the object that you receive here, and that's what the code, the callback here, it's doing, just assigning to the kernel all of that information about the middleware, because in the end, when the application runs, this is just a configuration phase, right? When the application runs, the kernel is the one that knows about the middlewares, and the kernel will pass those things to the other parts of the system that needs them, and we will see that. So that's that. This is an example of the resolve after resolving callback that the application implements, the container, sorry. The application, it's a container, but the implementation it's in the container class. And so let's go back to the part that we are looking here. So we have the kernel, now we know how it's getting all the information from. And now the handle method is called in the kernel, right? So before we take a look at the handle, let's just get an overview of what the kernel is. And for that, I prepared a little bit of documentation here, right? So the kernel, it is responsible. Let's just see what it's responsible for first, and then we take a look at the usage, what it's using. So it's responsible for handling the request, right? It's responsible also for terminating the request lifecycle. So meaning the kernel will know exactly what it's needed to handle the request, get a response, and then terminate that, answering back a response, right? And it also knows about the middleware information, and it's passing that to the router. So those are the two main functionality, right? The interface that the kernel has. It has a little bit more, but those are the two main ones. And you can see here that it's using a router, and it's also using a pipeline. And those two concepts, they are well, they are very standard concepts and patterns, especially for web development. Having a router, it's very common in a framework, right? And what the router does, it's that it knows exactly how to handle, not just handle, it won't handle directly, but it knows where to drive the code execution, right? Whenever a request it's passed to it. So it decides the execution path, right, to handle the request. And in the case of a web application, it delegates that uses the MVC pattern, right, the model view controller, delegates the request to the correct controller, so it knows about the routes, knows about the controllers, and the controller is the one that's responsible to provide a response, right? So the router has to know those things, the routes, the middlewares in the case of Laravel that implements that concept of middleware, something between the 2 points of execution. And so the router has a collection, right, of things. So it has a collection of routes, has a collection of the middleware as well. That's why the kernel first receives the middleware information, then it passes to the router. So the router, it's receiving from the kernel the middleware information. And it also has a collection of binders. So you remember that in Laravel you can use parameters in the root, and the Laravel tries to bind things for your objects or like models. Um, whenever you whenever you type hint them into your controller. So I think that's that. We will have to take a closer look, but I think that's that. And the router also, you can pass the parameters of the routes, right? And it also knows about the middlewares, etc. And you can also get root parameters from the router. Usually you access the router to retrieve your parameters that you didn't type hint into your controller. So that's another functionality. And the pipeline, it's just a helper to execute a lot of processes. And one process result, it's the input of the next one. So that's why you have that image of a pipe, many pipes connected to each other. So that's why the line, right? And it's a very common abstraction, right, in programming generally. But in Laravel here, the kernel, it's using that to handle the request, and we will see in a minute why it's using it. But it's the idea is that whenever comes from one pipe, enters into the other, and that goes on until the final destination, and then anything that comes out, it's the result, right? So with those things in mind, we can now just take a look at the kernel contract. Contracts, HTTP kernel. So you can see one of the extra functionalities that I didn't mention, it's the bootstrapping. And that's what we suspected, because the bootstrap process, it isn't finished until the kernel starts handling the request. So the kernel is also responsible for bootstrapping the application for HTTP requests, right? I think it makes sense to do that because the console kernel doesn't need to do many of the things that the HTTP kernel has to do to bootstrap the application, right? So I think that's why they delegated the rest of the bootstrapping of the application bootstrapping to the correct kernels, so you can separate exactly what each one needs. It also, well, the handle, it's the method we just discussed, terminate, and the other interface, it's just get application, and the application here, it's really the app container, right? So those are the main four ones. And now let's take a look at the constructor. So whenever the kernel it's called, it will, it's cute. It will call the sync middleware to router, right? And this sync middleware to router, it's doing, it's passing the information about the middleware to the router, right? And now that I'm reading this, the first time the kernel gets called, which we can do this, right? It doesn't have information about the middleware. So this call here, the first time, I don't think it would do anything. For example, if we just die on the router, yeah, the router doesn't have any information other than just the priority. and the priority is not here. Oh, it is. So this middleware priority that already is defined here. Yes, and where does that come from? So middleware priority. Oh, it's okay. Not coded here. So that's why it's passing, but nothing else, right? So this first call here, I think, it's just to, yeah, it's just to pass the middleware priority because the rest will be empty. So that's why it's called. Yeah, it still has some usage. But the groups and the actual middleware and aliases, they are not registered so far. They will only be registered, I think, when the handle gets called, right? So at this point here, this router, oh, yeah, the router already knows. How do this then? So yeah, we are going to echo and debug first, right? Debug. And oh, this is not going to work. Oh, maybe echo. So kernel 128. Yeah, it's the constructor here. This set global middleware, where does application builder, the application builder. Oh, right. It's in the callback. So whenever the global middleware is set to the kernel will also set that to the router by syncing it. Okay, makes sense. Does it make sense? It's kind of side effect because the router can be managed on its own, right? It's separate. It doesn't need a kernel. Well, actually, it doesn't make sense to have an HTTP kernel. Well, to have a router without an HTTP kernel, right? So yeah. Let's do rdump, remove it, and go back to the okay. So we know that when it gets here, everything will be already set, both in the kernel and in the router, right? So middlewares and the router will already have information about the roots And that we can just take a look here. So the application has the construct, right? And the construct has this base service providers registration. And inside here, it's read using this routing service provider. We already saw that the last episode, I think. So we go there, routing and routing service provider. Okay, routing. And you can see this call here, because we discussed that, because this is not, it will run right away, this service provider. It's not, what's the name? Got the name, but it's not delayed, the registration. This will be called whenever the application does this, right? Register new routing service provider, and all of this will be called. And then all of those methods will register something into the app. So in this case, it's registering the router, right? And the router has those dependencies, but it also it's registering the URL, and you can see that the callback for the URL registration here in the container, it's getting the routes from the router, so it's extending things as well. But I don't think that's what's loading the routes. I think it's really the constructor. Let me just double check here. Yeah. Let's take a look at the router constructor then. Routing, router. Events, route collection, and the container. Okay, and here, what does it have? Yeah, has the events, the container, the routes. It's a collection, empty collection. But in the kernel, the router already has that. Right? This. Yeah, the routes are here. Oh, no, it's empty as well. Yeah. So it's somewhere down below here. Right. So the first thing it's that the kernel does when it's handling, it's just to store the started date, well, the time, right, and date, of course, but and then it will try to handle, right, the request. It catches any exception and try to render a nice exception for us. So anything that our controllers throw, I think it might be handled here. And after it does that, it will, well, after it handles the request, it will dispatch any event, well, not any events, but the request handler, right, event, and then just return the response. Right? So let's take a look at the try here, inside the try. The first thing is to enable the method parameter override. And this we already saw in the request when we were taking a look at the request. This is a Symfony method to allow post requests to send a parameter to override the method. So a post could turn into a delete method by just reading that extra parameter. So that's enabling the Laravel. It's enabled it by default, right? And then it's sending the request through the router. This is a protected method from the kernel, and that's where well, let's just take a look here quickly. That's where the pipeline is used. So you can see that a new pipeline, meaning the helper, right, will be instantiated, passing the container. I imagine the pipeline also handles dependency injection and the reutilization of objects from the container, from the app. And we send the request, so the object, the thing that's going inside the pipes, it's the request, right? And it's going through, and here you pass the pipes, the actual pipes, right? In a line of execution. So those are the middlewares. So you can see here that the kernel uses the pipeline helper to just execute the request, but passing the request through all the middlewares first. And only then destination will be to dispatch to the router, right? So the concept of the pipeline is to just really make a helper class that will allow you to better control the flow of execution without duplicating a lot of for eaches and maybe error handling and logging and all of the stuff. And Laravel makes it more readable as well, using the usual structure here that you can just do something, receive back the object, and keep doing. So it's kind of reading like English. So new pipeline, send requests through pipes, then execute the dispatching to the router. That's the idea of the pipeline here. And here in the first line, this is just registering the request against the container. Right? This instance method here, it's the container method function instance. So you register an existing instance as a shared object in the container. So you just pass the abstract, what kind of the key for the concrete, which is the instance in this case, and it will do some logic here to update any other object that was bound to this container that might be using the instance, to just update it, right? So it will rebound it if needed. And one funny thing that I saw here in the kernel, that you do that, you register you attach the request to the container again. I'm not sure if it was already, maybe it wasn't. Yeah. This would go to the so it's just fine. Do that. No request here, right? Request. No. So just the request interface. But if we do here, still no request. Maybe it's not here. Maybe it's somewhere else. Just do this. Instances. and request is here. There. And if we do here, instance, no request. Yeah, so it wasn't here before, now it is. And the funny thing is that the facade, it's required to clear the resolved instance from the facade as well. I don't want to go inside the facade right now because I think we will take a look at that later. But here, what it's doing, and I saw that internally, it's just removing this request instance, a request instance that could be stored in the facade statically from the facade. So it feels like the facade is also a container of objects, and share those objects throughout the whole code because you can use facades anywhere in the code. But it seems that the facades collection is not connected to the app container. So if you do something into the app, you would have to remember to do something in the facade collection as well. It feels a little bit messy, but I'm pretty sure there might be a reason for this, and we will be able to take a look at that in the following reading. But right now, it's just, yeah, if this behavior happens all the time, I think could be improved, probably allowing the container know that a item being contained there also is contained inside facades. So the app would know, okay, I have to just, like it's doing here, right? It's worrying about that already, but just with the contained elements, it updates whatever you're passing here as an instance inside all the other bound objects that use that instance, but it's not doing that for the facade. So that might be something we investigate a little bit more. But yeah, I think it's enough for one episode. I think that the next one we could start by just playing around a little bit with the pipeline, just understand deeply how it works and the implementation, and then we could move to the bootstrapping, because this bootstrap here of the kernel, it does a lot of things. So it calls the app bootstrap with, only of course if the app it's not bootstrapped already, and it passes a lot of bootstrappers, which is those things here. So you can see load environment variables, load configuration, handle exceptions. It registered the facades, register providers, and boot the providers. We can take a look at that next episode. Probably this before the pipeline. So maybe the pipeline will be in the next one. But yeah, I think that's enough for today. I hope you enjoyed, and take care, and see you next episode.